Okay, in this section, we're going to talk about async functions. An async function is a declaration that defines an asynchronous function which returns an async function object. Okay, so here's the things you need to know. When called, it returns a promise. When it returns a value, the promise will be resolved with the return value. When it throws an exception or some value, the promise will be rejected with the thrown value. And it can contain an await expression. Now, await expressions are kind of used for, I'm going to say, executing promises in a waterfall fashion, let's say, or executing promises concurrently and then awaiting some synchronous execution of a method to aggregate values. So keep in mind that when you look at this and you think about calling web services using this, look at the RxJSX package. There are functions to call web services concurrently and do aggregations with that. And of course, Node.js has the async module, which is beautiful. You can do parallel and waterfall type of synchronous calls with that as well. Okay, so let's get back to promises. So you have this async function, and you have this, and it returns a promise, and it's sort of similar to what we just discussed. But the important thing to use is this await expression. This thing pauses the execution of the async function, waits for the past promise's resolution, and then resumes the execution. And it could return it returns the resolved value. But typically, you'll have several wait expressions where you're doing executing an async result, getting back the value, executing, getting back the value, and then you're finally resolving. So I kind of like view it as a kind of waterfall type of mechanism. Okay, so let's look at this example. Okay, here's a function where you resolve after 4 seconds. You return the promise value. You got a fat arrow anonymous function operator, and you basically say resolve. You set this timeout and you resolve after 4 seconds. So the function resolve after 4 seconds does a resolve after 4 seconds. Okay, and basically the set timeout says execute this anonymous function after 4 seconds, and all it's going to do is resolve the argument value. Okay, so what you could do is you could define an async function called add1, and when you define this function, it takes an argument, and basically what you could do is you can call the consumed promise value, which is, I'm calling it resolved after 4 seconds, and I pass in a value of 10. And the await there pauses the execution and waits for the resolution of that promise before it moves on to the next statement. So then the next, okay, so the value comes into constant A. After 4 seconds, this value of 10 comes into constant A. I do a resolve after 4 seconds and I pass in a value of 20. This thing doesn't await. It resolves after 4 seconds. Constant B. Okay, so then after 8 seconds, constant B is then defined. Okay, because I waited 4 seconds for this guy to give me a 10 value in this A variable. I waited 4 seconds for this a function called to give me a 20 in this variable. And so now I'm adding over here 10 plus 20. But if I call this thing and I pass in a value of 5, I'm adding 5 plus 10 plus 20. So this return value returns the resolved value of the async function. these resolves are resolving to values here. So if I call add 1 with a value of 5, and I have a callback saying that then, and then I have this anonymous function with this fat arrow operator and say v console log v, it should print 35 after 8 seconds. Okay. Now, like I said, it's to me we've been waiting for, okay, it's kind of ironic, but we've been waiting for things like this in Angular code. Like we had this success and failure block with HTTP, and we have different things now with RxJX and observables where I can call web services in a waterfall fashion and aggregate results. I could call them in a concurrent fashion, and so there's starting to be some reasonable things in the client to do these types of things. But when I think about this, I think about stuff I had in Node with async module and calling two web services and doing them in a waterfall fashion, or what step fashion. I forgot the name of the function, but basically you're doing these asynchronous calls, and you have to do it in sort of this waterfall fashion. Like for example, with this second function here, I called it with a 20 value, but I could have used this constant a. So after 4 seconds, this constant a could have been 10. I could have passed it into this function. Okay, so that's another example of how the async module in Node helped me a great deal, and now I'm starting to see some of this nice stuff in Angular and in ES6, etc. Okay, so now so this is one application of using the await expression and an async function. My personal opinion is there's still a lot going on here, more than I really need to see. A lot of keywords, a lot of stuff, and I know JavaScript is like that in general, but just be careful when you use this thing for the right reasons. And like I said, if you're calling web servers, always look at the HTTP client module, the application to observables, and the RxJX package. If you're in Node, look at the async module, some new things that might be coming up with TypeScript in Node. Because what I find is if you're calling too many asynchronous web service calls in Angular code, it probably should be pushed to the middle tier in the Node level, or even back further. So, but anyway, let's move on. So here's add 1. Now let me show you a different. Okay, let's move on to the async function add to concurrently, and in that case, I don't put the await in front of the expressions of the function calls. I put the await in the resulting values. So in this case here, p_a has to be defined. So this will execute. This takes 4 seconds. But this is executing as well, concurrently, and that takes 4 seconds. So as both of these things are ready to be added, we've really waited 4 seconds. So this is more like a parallel execution of promises. And then, like I said, if I add to concurrently, I pass in 10, I get 10 plus 5 is 15, plus 15 is 30, but I get it after 4 seconds. So the callback to this guy uses this anonymous fat arrow operator function, and I just log the value of the callback. And I'm going to say the resolution of the async function. So this v is the resolution of this async function. Both timers are created and then both are awaited. Okay, so here these two awaits are basically waiting for these two timers to complete, but they're running. The two timers are running concurrently. Okay, so let's look at the async await example, and let's take a look at what that code might look like. Okay, So I have this async await function. I basically execute it here with the button click async await, and 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 what I do is I begin the async await. I resolve after 4 seconds. I return this new promise, and instead of passing in a resolve and reject, I basically just pass in a resolve, and I set the timeout of the resolve of X, and I execute that in 4 seconds. So this resolve after 4 seconds executes this set timeout. It executes this anonymous function in 4 seconds, and this anonymous function just basically resolves the X value. And then I define an async function which returns a promise, and when I invoke it, this await resolve happens after 4 seconds. This await resolve happens after 4 seconds. And basically when I pass in this 5, I say return 5 plus 10 plus 20. So it prints 35 after 8 seconds. Let's see. I guess let's move on. And then we have add concurrently takes an argument X, and that resolves after 4 seconds. 5 resolves after 4 seconds. 15. So this is 5 plus 15. Both of these execute concurrently, but we're waiting for each result before we do the operation of add. So when we do add concurrently 10, we are returning 10 plus 5 plus 15, but this return is really a promise that's getting resolved. Okay, so when I get the call, when I define the callback, I say v is console.log v prints 30 after 4 seconds, and then I end the async await. Okay, so let's take a look at those two. It's going to be hard to determine how long it's really taking, but let's just look at the code running example, and we could take a look at what transpires here. Okay, so it's this async await button that's executing, and if we execute it, we see begin async wait. Oh, and it's already ended, the function console at the end. So first you see 30, then you see 35. So it's a very simple result, but at the same time, it's exhibiting waterfall type execution and parallel type of execution. So add 1 is the waterfall method, add 2 concurrently is the parallel method, and all we're doing is printing the value.